morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So, today in this video class I am going to teach you about Unit 5, Undecidable Problems. Okay, Undecidability. Unit 5, Undecidability. So, the problems may be differentiated into two types, that is decidability and undecidability. So, the unit 5 fully deals with undecidability. Okay. So, first of all I want to give one small example. It comes under two different types of languages, undecidability and decidability. It comes under two different types of languages. One is recursive languages and another one is non-recursive, recursive enumerable languages. Okay, so we will say it as RL and RE, recursive languages. You have to understand what is recursive languages is it is decidability. So we can decide a problem. For example, I want to tell you you just go from here to there. So you can decide within this minute, this second or this hour I can travel this distance. You can decidable. But I cannot tell you the exact place of you. So you cannot decidable, okay. So you cannot decide the time, you cannot decide the distance, anything you cannot decide. I will tell you, just you want to go from, that's alone, that is undecidable. You cannot predict, you cannot decide, clear. So that comes under, in this theory of computation, first 4 units you talked about some machines, but later on they studied about what is the problems, in a computer environment, that how the problems can be solved by a computer. Okay. So types of recursive languages I will explain you. So if you see the recursive languages, it has algorithm. Okay, it has algorithm, yes, it has algorithm and it decides the problem. Okay, it gives an input and it will get an output. So it has algorithm and it decides the problem. Decides means we know the input as well as output. Okay, the problem should be solved, we can solve within a particular time period. That is recursive languages. Okay, but it has algorithm. And recursive enumerable languages, it doesn't have any algorithm. And problem also not decided. Problems not decided. Okay, so I can say one example. This comes under real-time problem. Problems that dealing with the particular time, right? That is, but it doesn't have any algorithm and it decided by at the time. That is undecidability. That we will say recursive enumerable language. It doesn't give the answer exactly. It doesn't give yes or no. Maybe it forms a loop or it may struck anything happened in here. But here it is give the answer yes. Solvable, it says yes or no. But here solvable, it takes time or it delays, right? It can work out, it try to work out. So recursive enumerable. What is decidable? Decidable and recursive language both are same. Okay, problem can be decided. That's what I told you. I can decide the problem. I am giving a addition of 2 numbers into the computer. So within fraction of time the problem it is decided and the algorithm it's work out within a particular time period, nanoseconds, the problem should be worked out. Decidable problem, the problem, yes, algorithm, the same thing, algorithm, yes, and decided, okay, we can solve. It gives answer, yes or no, yes or no, clear. But here undecidable problem, the problem cannot be, comes under recursive enumerable. The problem cannot be decided, clear. It says the answer yes or it forms infinite loop, it doesn't decide it. It cannot clearly predict the answer. That is recursive enumerable. Through one diagram or undecidability. Through one diagram I will explain you what is recursive language and what is recursive enumerable, right? So this is the input. If the algorithm or problem, and this is recursive language, okay, recursive machine. It gives yes and it gives no. This method or this thing is, we will call it as recursive. recursive language machine or recursive language machine. Recursive machine. Okay, yes, the algorithm predicts yes or no. It tells yes or no. But recursive enumerable enumerable machine. Recursive enumerable machine means the same algorithm or problem or machine, if you gives the input and it says the output yes, or it forms infinite loop. That means it cannot give the answer, it tries to work out and it forms infinite loops. That is recursive enumerable. Okay, and if you see this recursive enumerable concept is work out, sometime you may see the real-time machine, it forms a loop, again it loops. Okay, and for loop, while loop, that concept comes taken from this recursive enumerable machine. Clear? So this is the difference between recursive enumerable and recursive language. That is decidable and undesirable language. And in our 5th unit, we are focusing about undecidability, not decidability, undecidability, that is recursive enumerable machine only. Okay, recursive enumerable machine. Right. So what is recursive enumerable machine? I told you it gives the answer yes or no. Right. Right. For that first language we want to know diagonalizational language. Diagonalizational language, that is called LD. LD. This is very important 4 mark or 8 mark question. LD. Okay. So diagonalization language. The techniques to design a diagonalization language is, for example, if you have a matrix like this or diagonal matrix like this, so whatever this is ith row, that is this is j. For example, this is j and this is I. This is row and this is column. I means row and this is column. Okay. So inside the diagonal, if you have value 1, 2, 3, 4, 1, 2, 3, 4, etc., 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 etc. If you have 0, 0, 0, 0, 0, 1, 0, 0, or 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0. If you have the diagonal value like this, what it means is, inside the diagonalization vector, if the value is 1, it means the language is present inside the particular what you have given. For example, 3 of 2, 3 of yes, 3 of 2, yes, 3 of 2, the row 2, 3 given. If this is checked here, if it is 1, that means this particular language is present inside. This particular string is present inside the language. That means in the diagonalization language, we have more and more diagonalization language have to be kept in this diagonally. Okay, this is one language. Individually we can do more language, but apart from that, many languages we can given inside the diagonalization language. So I want to identify 3, 2, for example. If it is a row is 1 and the language is present inside, the string is present inside the language. If it is 0, the language is not present inside the language. Okay. So what made it is easy to design a diagonalization language is, that's what I told you. Value 0 means not in L of Mj. Value 1 means not in language. Okay. So how to, the tricks to construct a diagonalization language is, complemented the diagonals. If you complemented the diagonal, so it becomes like 1, 0, 0, 0, remaining everything is 0, 0, 0, or whatever it may be. If you complemented the diagonals, the diagonal value should be like this. Except the first one, everything is 0, 0, 0, 0, 0. That means the diagonal value alone is not present inside the language. We can made it like this. So it means the main concept of diagonalization language, the problem is undecidability. That is, the diagonal values 0 means that is not present in the language. Diagonal values 1 means the string that is present inside the language. So we have a theorem also. Just you read your standard other book or the notes I have given, you can understand the undecidability problem, that is diagonalizational language. Okay, thank you.